Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And in this short video, we'd like to show that the variance of a constant times a random variable is the same as, or equals, the square of the constant times the variance of the random variable. So mathematically, what would we like to show? We'd like to show that the variance of a constant times a random variable is the same as the square of the constant, so k squared, times the variance of the random variable. Okay. Now to show this, we're going to rely upon a number of identities. So we'll rely upon two previous facts that we've proven. We're going to rely upon that the expected value of a constant times a random variable is the same as the constant times the expected value of the random variable. And we're also going to rely upon the fact that the variance of the random variable in expectation form is the same as the expected value of the square of the random variable minus the square of the expected value of the random variable. Okay, so let's do this. Okay. Let's do this little proof. Okay, so this proof. Okay, so we want to show that the variance of k times a random variable, a constant times a random variable, is the same as the square of the constant times the variance of the random variable. Okay, let's just do this first of all this way. Let's let y equal kx. Okay. So now that we know that y is equal to kx, we're just doing a substitution of variables. Okay. So y is this new random variable. That is the constant times the original random variable x. So let's have a look at this. Okay, and from the second identity here, we now know that the variance, of y is the same as the expected value of y squared minus the square of the expected value of y. Okay, so we know this fact from this particular identity here. The only reason I did this particular substitution is so that we can actually see k of x being transformed across here. Okay, so this is the same as now. So this is equal to the expected value, okay, of the square of k of x. So it's the expected value of k of x squared. Okay, we're substituting back in our y for our y, k of x, minus the square of the expected value of k of x. Okay, so that's what we have here. So we've just I suppose we've done a substitution for the original variable just so that we can see it being applied across this identity, and then we've reversed the substitution to give us actually what we're really trying to do. Okay, so let's square this particular term here. Okay, so this is equal to the expected value, okay, of k squared times the random variable squared, okay, minus the expected value, or the square of the expected value of k times x to be squared. Okay. Now, our rule up here says that the expected value of a constant times a random variable is the same as the constant times the expected value of the random variable. So we can take this constant outside of the expectation, and similarly we can take this constant k outside of the expectation. So this becomes k squared times the expected value of x squared minus, when we take the constant k out, it's k times the expected value of x, all to be squared. Okay. Now you can see that we can actually do the squaring of k here and also do the squaring of e to the x. So this becomes k squared times the expected value of x squared minus k squared times the expected value of x, all to be squared. There's a common term here, okay, k squared, let's take it out. This becomes k squared times the expected value of x squared minus the expected value of x, all to be squared. Okay. Now by definition, Okay, we know that this particular term here, the expected value of the square of a random variable minus the square of its expected value, is the same as the variance of the underlying random variable. So actually this now becomes equal to k squared times the variance of x. Okay, so what we've actually shown here is this, is that the variance of y, okay, which, don't forget, is equal to the variance of kx, okay? We've shown that the variance of kx, which through the substitution is the variance of y, is the same as k squared times the variance of x. So what we've shown in this particular proof here is we've shown that the variance of a constant times a random variable is the same as the constant squared times the variance. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope this video was somewhat helpful.